Hello and welcome to Got Power Incorporated. This is going to be a demonstration of the Peripatia Regenerative Acceleration Generator. Here we have a Ryobi bench grinder. It's 120 volt, 2.1 amp, 3600 RPM induction AC motor with a 1/2 inch shaft. Attached to that is a 10.5 inch steel rotor with 18 magnets with a 35-pound pulling weight arranged in a north-south configuration. And here we have the patented coil which causes the regenerative acceleration effect. It's made out of an E-core material that's frequently used in transformers. And on the center leg of this E are two high voltage coils. Those are the coils that cause the regenerative acceleration process to take effect. And surrounding that is a high current coil which is going around the two outer legs of the E coil. And that's how the coil is constructed. Currently there's one on this. This particular rotor may support up to 5 or 6 coils. The next generation of rotor is going to be able to support 8 coils, and currently this coil produces about 13.5 watts. The next generation with the new core material is going to produce between 30 and 50 watts per coil. Here we have a RPM meter so that we can tell when the regenerative acceleration effect is taking place. Here we have a Variac which is currently set to 120 volts, and we will use that amount of voltage to get the process started, and then we will dial down from there to establish an equilibrium state somewhere around 2800 RPM and 100 volts or a little less. Here we have the control panel, and we have an emergency on-off switch here. We have the high current coil here, which is the coil that produces the power and is subsequently read by this meter, which is a voltmeter, and it goes through a 10 ohm load located here so that we can calculate the watts that the coil produces. And here we have high voltage coil number 1 and high voltage coil number 2, which induces the regenerative acceleration effect. So now what we're going to do is start the process by giving the rotor a little bit of a spin and then flipping the switch here to start the power, and then adjusting the Variac up to 120 volts. And as you can see, we're starting to get acceleration here. And now we'll spin this baby up to about between 2800 and 3000 volts, and then establish an equilibrium voltage, at which point the rotor is neither speeding up or slowing down. We're currently at 1200, 1300, 1400, 1500. When it gets up to about 2200, we'll start to dial it down. Now we're backing off on the voltage. As you can see, I'm down here to 100 volts now, and I'm going to go down to about 80 volts and drop. We've actually got the spinning up to 3200, and that was a little bit too high, so I'm dropping it back down to 2800. Now I'm going to up the voltage until we see that the speed is increasing. That's about 95 volts or a little more. There we go, it's starting to turn there. So we're currently at about 100 volts. Turn it down just a tad. And now you can see that the voltage is going, the speed is going down slowly. And we're at about 95 volts here, about 95 volts. And now what we're going to do is engage the high current coil, and you'll see that the speed goes down dramatically. Right now it's going down about, and we're now producing 7.70, and it's going down by 50 rotations, RPM polling. And now we're going to engage the two high current coils, and you can see now we're experiencing some acceleration. Where before, when we had just the high current coil activated, we were losing RPM at 95 volts, and now we are gaining RPM slowly at first, but as we get higher and higher in RPMs, it'll start jumping higher and higher. All the while we are only putting 95 volts to the motor. And actually, as the speeds come up, once we hit around 2800 RPM, we can actually start reducing the voltage to the motor, because the coil becomes more and more efficient. And right now, with the high current coil, we're getting 10.43 and climbing. You can see we're going to be hitting 11 volts here very shortly. And right now we're starting to see the machine increase by 50 very quickly now, going up. Now at 3000 we can start to dial down the power to the motor all the way down to about 88 volts. And at 88 volts, you can see that the process is speeding up. 33, 34, 36, 38. That's with just one high voltage coil on, the other one off, and the high current coil on, which is producing 11.64 volts across the 10 ohm load, which is about 13.5 watts. And the system is still continuing to accelerate. And right now we're only putting about 88 volts to the system at about a 1.9, maybe 1.8 amp draw to the motor, which is less than what it's rated for. This is a first generation coil, like I said. The second generation coil is supposed to hit between 30 and 50 watts, and we will be able to arrange the coils such that on the new rotor we'll get up to 8 coils on one side. And this system is going to be able to take 2 coils on each side and a little bit stronger motor eventually, and be able to have regenerative acceleration and excess power as a result. This concludes the demonstration of the regenerative acceleration effect. Thank you very much.